TiMax panLab utilizes a completely bespoke amplitude-based panning algorithm. The algorithm has been designed from the ground up to get you up and running with spatial audio in under 5 minutes. For most common use cases, you can simply drag and drop your loudspeakers onto the panner and get to work. However, we've built some powerful functionality into the software, enabling you to work in 3D and in more complex spatial deployments. Carry on watching to find out more. First, let's take a deep dive into stacks and zones. If you're interested in spatial audio, I'm guessing you're familiar with a standard panner. A basic example might be a quad panner, a 5.1 or even a 7.1 panner. You can think of a zone as a highly flexible panner. A zone contains speakers, and the shape of the zone is defined by the position of all the speakers within it. TiMax panLab works out the geographical center of the zone. When a source is placed towards the outside edge of a zone, panLab will distribute most output energy to the nearest two speakers, in this case, speakers 1 and 2. When you move the source towards the center of the zone, the energy will be spread out until we are distributing audio to all speakers equally. Whilst the source is within the shape of the zone, the output power is normalized to a constant level. This is called equal power panning. Each zone has an additional property called the zone boundary. This is an area outside the zone where its influence diminishes over distance. When you move a source away from a zone through its zone boundary, the amount of output power distributed to that zone decreases the further away from the zone you move the source. The panLab panner can contain multiple zones, and you can layer zones on top of each other to create complex spatial environments. Here's a practical example. Here we have two zones at the same height, an auditorium zone and a stage zone. Because the two zones overlap, you can move a source between the stage and the auditorium. You can fine-tune the transition between these two zones using their respective zone boundaries. So far, we've just been working in 2D. But what happens if we want to place zones on top of one another in 3D space? To achieve this, we have developed a feature we call stacks. A stack is a vertical stack of zones. Here we are viewing one from the side so we can see the vertical axis more clearly. In this example, we have zones A, B, and C. Because our source is positioned between zones A and B, the algorithm will distribute our audio between these two zones. If we were to move the source downwards, the distribution would change. Here, it would be distributed purely to zone B, and here, it would be distributed mostly to zone C.